welcome to you all this morning, and thank you for joining this particular webinar hosted by Phase Pacific, myself, along with Black Duck, our partner. So the topic is around generative AI and how it impacts, particularly in the environment of software development, how it can benefit those developing software, but also how we need to be very mindful and aware of the risks that are still present, even when you're using AI, and how AI can be used to actually help mitigate those risks. So today I'm joined with my colleague from Black Duck, Priyank Sharma, who is a senior application security consultant at Black Duck. He's worked for many years, over 10 years, helping customers and organizations understand their cybersecurity posture and helping them embed security into their software development process. Now, just before we jump to Priyank, just a few housekeeping things that I'd like to mention. There is a chat associated with the webinar. You're welcome to type in your questions as we proceed. We'll open the mics towards the end of the session. But certainly we do welcome your questions as we progress through the presentation today. So without further ado, Priyank, I'd like to hand over to you and welcome for today's session.
Thank you, Frank, and good morning. Welcome, everyone. So as Frank said, I think today's discussion is going to focus on how we can securely create software with the help of AI-assisted tools and solutions, and how can we improve our software supply chain to make sure that we are producing code at speed, but at the same time without compromising on quality. So I'm sure all of us have noticed a trend where most of these talks start with a attention-grabbing headline. So this is my headline, a brief timeline of how it all started. So in the mid-90s, a government contractor created an artificial neural network. Now, this AI soon gained self-awareness and started to spread from system to system until it finally reached the nuclear launch system and launched a full-scale attack. Well, this may not exactly be the real timeline. If this sounds fictional, then you're right, because it is. However, I do want to talk about the real timeline, which I think most of us are already familiar with. Now, in late 2022, when OpenAI launched ChatGPT, it caught everyone's attention, including developers, and they immediately identified some use cases that can now be solved with the help of AI and large language models. Of course, it wasn't perfect, but things started to get better with every iteration. And now to a point where in 2024, you notice that AI and LLMs are everywhere. And they are a part of everything, right from the way we search for information, the way we write code. They have influenced every piece of technology. Now, for the purpose of today's session, I want to translate this into a really, really fundamental software delivery construct, something which we are all familiar with, our software application. Now, this could be a web app, a mobile app, an IoT device, or a web service. But we know that it is typically built with a combination of your proprietary source code. Now, this is something which your developers are writing. This is essentially your IP. We also add some open source components. These are mainly open source libraries or code snippets for functionalities that already exist in the open source world and the functionalities that you essentially do not want to recreate. You may also have some pieces of third-party vendor libraries or binaries and licenses from other vendors. And usually developers then finally wrap all these capabilities with an API and then throw in some deployment configuration settings, which makes part of the makes up the deployment configuration layer. Now, the quick question we can ask is, what do all these things have in common? Now, fairly straightforward. Of course, they're all written by developers, and they use some language and they rely on frameworks for interoperability. Now, for our discussion today, especially with the AI-assisted code generation, we will focus both on point 1 and 2.
So, Priyank, what stands out to me is that there's a lot of open source code being used, and a lot of that licensing is reciprocal. So, what does that mean to companies with respect to compliance?
Great question, Frank, and good spot. I think you're looking at the example on the screen, and it clearly shows that in this example, more than 67% of code it has reciprocal license obligations. Now, what that essentially means is, since a developer or a user benefits from open source, they are obligated to reciprocate or contribute back to the community. I'll give you an example. So we all have heard of GPL and AGPL as open source licenses. Now, while GPL license is sort of ambiguous in its obligations, AGPL explicitly states that you have to follow reciprocity obligation. And now what happens is, because of this particular reason, organizations are very, very careful not to include any open source code or component which has AGPL license, because it can have serious, legal consequences.
Okay. And in terms of API security, how do you view API security and its level of importance when it comes to development?
Fairly similar, because as they say, APIs are everywhere. And but when you look at the APIs from an SCA or an open source scanning lens, it's not very different, because they are also referencing some open source libraries or dependencies or components. So an efficient SCA scan can help you identify vulnerabilities in those open source libraries which your APIs may be referencing.
Thank
All
you.
right. Perfect. So just to set a little bit of a context before we look at the DevSecOps life cycle, I think we can all agree in the last decade or maybe a lot more, a lot of things have changed, purely in terms of how the software is delivered, how teams and functions go about serving this purpose, where you have team practicing various software development methodologies, right from agile to CI/CD automation to full-scale DevOps. But I'm sure you have noticed that most organizations are somewhere in the middle. And when I say somewhere in the middle, what I mean by that is, we may have, of course, an agile process in place, and then we may also be automating developer workflows, and we may also have some automated testing, which includes some CI/CD process and continuous deployment pipelines. Now, the big question is, once we start sort of enforcing AI-assisted development and make that as part of our DevSecOps process, this workflow can start to get a little complex. As you can see on the left-hand side of the screen, once a developer or a development team starts using an AI assistant, they start, of course, generating code at a rapid pace. Now, what that means is, once the code is generated, it will eventually be picked up by a CI/CD pipeline from a Git-based SCM. And the CI/CD pipeline will, of course, run a SAST or SCA scan and is going to generate some artifacts at the end of it. Once issues and vulnerabilities are discovered, these will be triaged and assigned back to the development team to create the required fixes. I think we're all familiar with the standard process. But the key point here is, AI-enabled development process, once it starts improving the development velocity, it will also start applying pressure to our development pipeline and can open new opportunities or new attack surfaces.
So that acceleration of code development using the AI assist will also then speed up the whole code commit. And I imagine that the entire software development lifecycle also needs to be kept up.
Oh, 100%,
To,
Frank. I think you're
yeah.
absolutely right, because like you rightly said, this ripple effect of generating faster code will trickle down, and all the downstream processes such as testing, development, deployment, monitoring, even on the production side, they have to keep up to keep pace with the left-hand side of your SDLC. So you're absolutely correct. And we talked about these risks when we looked at the question that Frank raised. Now, the bigger question here is, all right, we have our AI-assisted code development. What kind of impact can it have through this ripple effect? So broadly, three main categories of impact. First is the AI's impact on code. Now, in this case, the principle of garbage in, garbage out could not be more true, because the quality of your underlying AI solutions that your development team is using, the way these models are trained, the kind of data that has been fed in, are these private LLMs, are these public LLMs, all these conditions will decide the quality of the code which is going to travel through your supply chain. What it also means is it can also impact the resulting context. So let's say you are getting different results from the same type of prompt. That's not good as well. Again, it points to a bigger problem of your LLMs not being trained smartly enough or cleanly enough to provide the data that you need. The next impact is on operation, and this ties back to the previous slide where we were talking about the need to secure our pipelines. Because if the dev pipeline is not ready to accept the process changes that are getting fed into it, at some stage you will see that this will start having an impact on your workflow, and this will result in defect leakage. And finally, with every DevOps process, there is a strong element, a softer element of culture as well. And the problem is, if we start putting an implicit trust in the models that we have created, it can result in a little bit of complacency. And this may also over time impact the skill set, which may stop us from challenging the model that we are training. We stop challenging the trust that we have maybe incorrectly placed in the model that we are developing. Some people refer to this as GPS development or shadow development. And what they mean by that is when development teams start receiving instructions from AI and they start treating those instructions as complete black boxes without having any real access to the internals of the development piece, that can be a huge risk. And you can imagine it's not a great development practice to begin with at all. Now, to put it simply, I think we talked about a few issues here, but if we wanted to just narrow it down to maybe a couple of key points, which you can take back, and once you start talking to your teams, you can use these points to help them inspire into action, then I would say, I think one of the main or biggest risk category that can generate as part of this AI-assisted development is your security risks. And now this comes from, of course, creating weak code really quickly, because now you have the pace, but your AI models may be referencing vulnerable libraries, or they may be ingesting malware into the supply chain. And to add to this, the second category of risk is the license risk. Now, this comes up when the AI model picks up code snippets and pieces of open source it was trained on without taking into account any license related requirements. And I think this goes back to the question that Frank asked earlier about reciprocal licensing. We can end up with reciprocal license or attribution requirements that the AI model failed to uphold. And of course, these are very serious legal challenges that an organization may have to then navigate.
So can I get some clarification? Just in terms of pulling in vulnerabilities, that's probably well understood. When you talk about ingesting malware, I have this Pac-Man image going along, chumping up all this malware. So maybe you could expand on exactly what you mean by that.
Yeah, Frank, I think malware is a big concern for a lot of organizations today, and it is I would say a very vulnerable entry point when it comes to your supply chain. And to be fair, I think this can happen unintentionally, because the AI model may not always recognize code vulnerabilities, especially if these vulnerabilities are subtle. And sometimes, AI can start making suggestions and provide you with code snippets which are susceptible to injection attacks or privilege escalations, or similar types of security flaws. So I think it can be unintentional, but again, uh, to your point, I think the AI generated code with known security weaknesses and malware increases the risk of a risky supply chain.
Thank you.
So we looked at the two broad category of risks, but there's no single point of entry through which this risk enters your supply chain. And one of the biggest reason for this is, if you look at this data on the screen, you will notice that a large percent of organizations truly believe that this happens due to the fact that they are not either testing enough, or they are not able to test enough frequently enough. So, and the reason for that is fairly straightforward. Once you start writing code which is assisted by AI, you are of course generating um, proprietary code. You're also using open source code at a rapid pace. This code may already have some existing vulnerabilities or weaknesses, and it may also introduce new vulnerabilities as well. Now, once you discover a security issue, you already can see that there is a bit of a lag from the time you start, using a model to the time where you actually discover a security issue. And then comes patching. Finally, you patch everything and update the software. You push the final build back into the delivery repository. Now, all of this combined makes up the window of opportunity for an attacker to exploit this. And this window of opportunity will start to get bigger when AI is involved. Now, this is a concern from a if you look at the point of view from our customers and our end users, it is a big concern. And I think one of the main goal of securing your supply chain is to shorten this window. How do we close this window of attack? We primarily can do this in three ways. And if we, again, go back to the left of the SDLC, we start looking at the developer ecosystem. We start by empowering our developers. How do we do that? We enable them by providing the right remediation advice at the right time. Now, this advice can come in from an AI-enabled security tool. It can come in from a tool within their IDE, so their workflow is not interrupted. It becomes part of their developer workflow, and it provides them the right kind of advice at the right time to take corrective action. Now we start moving from the development side further to the right in your SDLC, and we approach the CI/CD pipeline, and we again go back to this idea of securing your CI/CD pipeline. And what that means is, again, strengthen your pipeline by making sure that the repositories that are part of your pipelines are not accepting unauthorized changes. There is no compromised repository. Your build process is not compromised. If you are deploying packages into let's say a repository management such as Artifactory, for example, that repository is not compromised, so that your package process is locked in as well. And then finally, this cannot happen without making your private LLMs and AI models secure. So we have to ensure that the code is secure at the source. So if your source is your private LLM, we need to make sure that your private LLMs are producing good quality code. And we also have to make security testing a priority in the organization, for the simple fact that this must reduce friction for quick adoption.
I see you've touched on training, and I think training is very critical. Very good points that you've made throughout this whole slide. But I think training is very important, particularly given that you can't expect all software developers to be completely knowledgeable when it comes to security. How do you view training, particularly training for software developers and helping software developers so that they understand the security aspects and can develop much better secure code?
I agree with you, Frank. I think you said it rightly when you said we can't expect developers to be security champions as well. Of course, security is a big part of development process. But I think what we can offer is for our developers to maybe understand the security fundamentals so that they can identify potential risks as early as possible, and kind of become the first line of defense against vulnerabilities. So, and I think I'm glad you asked that question. We'll take a look at a real-time example where we can make our security solutions offer certain suggestions which can help developers make sense of what's going wrong with their code, and then help them with some remediation advice as well. So it's all part of that education awareness life cycle.
I think it's important.
It is. Now, if I can quickly align these 3 points to our SDLC. Now, I'll not go through this in detail because I understand this is a fairly standard workflow we are all very familiar with. But the key point here is, as we've been saying, developers can actually start testing early, right from their IDE. And this gives them an opportunity to, first of all, mitigate the security risks that we talked about earlier, the one broad category of risk. They can fix it starting from their IDE. Also, once the code is ready to be merged into your pipeline, this also gives them an opportunity to run SAST scans to mitigate security risks. When it comes to license risks, your full-blown SCA scan, which is going to run as part of your build process, I think is a better option to take care of license-related, compliance-related risks. Now, it's not limited to these 2 scans, because we have seen different teams have different requirements, and some also prefer to run some sort of an IAST test which can supplement your QA processes. And some teams also prefer to run some type of task scan in production, which acts as a continuous monitoring of your applications, looking for vulnerabilities, continuously scanning your websites for resiliency. So that's an option as well. But the key point again is a good best practice we have seen with a lot of organizations is eventually they would try and merge these processes, because if these all scanning methodologies, different security processes, if they are managed from a single platform, then it's a lot easier, as you can imagine, to manage, maintain, report, create dashboards, share it with your end users, share it with your management. So it just makes the whole process a lot simpler and easier to manage. And at the same time, we can increase the efficiency of this entire process by taking 2 different types of developer security enablement into account. So first is, of course, preventative, where we are enabling our developers to take up preventative measures at the source by becoming more risk aware. And then finally, on the right-hand side of the pipeline, once the code starts traveling through this pipeline, we provide the right kind of training and information, which Frank was alluding to earlier, right kind of developer training, so that they can pick up the issue at the right time and then fix it as quickly as possible. Now, as we promised, this is a quick example of how do we, when we start to visualize the next generation DevSecOps, where a security platform which is using AI to empower our developers, what's that going to look like? So this is an example where we have identified an issue as part of a SAST scan, And rather than providing a boilerplate, vague technical description, which can be a little confusing and stop developers from really acting on it because they don't really, get a gist of what's really happening. The assistant in this case has published a concise summary of the issue, because the platform is not only trained to provide the summary for a specific programming language, which it can, of course, but also it also takes into consideration a lot of security risk-related best practices as well. The platform also maintains the complete context of the issue by systematically breaking it down into clear steps. And this is really helpful when a developer tries to go back and make sense of how did we actually arrive at this issue? How can I replicate this before I start looking at fixing it? So once you have access to the issue, then comes the next step of how do we remediate this? How do we patch or fix this? Now, in this case, the platform is also, because it is using a private LLM, it is going to provide you with a fix or a fix recommendation, which is essentially a code snippet which a developer can pick up, quickly test, and then replace the affected part of the code base with this new piece of code that the platform has provided. So if I were to summarize very quickly, I think what we talked about today, we focused on a few key areas. We were focused on supporting the existing developer ecosystem, where we talked about supporting developers on the left-hand side of the SDLC within their IDE, provide them with the right kind of tools, AI-assisted security platforms with remediation and guidance information. We also talked about securing your CI/CD, because it's an essential part of your supply chain, and we have to make sure all the repositories, your build process, your package process is secure, because again, it is all now sort of trying to withstand the pressures of AI-assisted development and the speed at which your development is now progressing. Frank talked about training. Again, very critical that we provide training and, of course, cultivate some higher standards for development and CI/CD within our organization. And this goes with the fact that, again, AI-assisted development, it is picking up, it is everywhere. But again, it's an evolving situation. So any strategy that we adopt must take into account that this is a long-term process, and we have to sort of create a vision for that as well. Now, finally, to wrap things up, I wanted to highlight that we at Black Duck can support you along with FaZe to formulate a strategy for secure AI-assisted development and test within your organization. So really happy to be a part of this webinar, and I will hand it back to Frank.
Thank you, Priyank. That was an excellent presentation. So really the message is not to shy away from AI, pardon me, not to shy away from AI, but rather deploy a suitable strategy for adopting it and using it for its benefit, and understand the risks that are associated with that. At this point, I'd like to sort of go to some Q&A. So we do have a question that has come in. So the question reads, how much of these risks, insecure code written by AI and license violations, are we seeing in the industry? Priyank, do you have some data points there on how much you're seeing in the industry at this point in time?
I think it's a good question, because, as I said, a lot of organizations we have seen are early adopters of AI-assisted development. And I would say that what we have seen is they are using it for different purposes. So for example, if you look at the development lifecycle, a lot of teams are now using AI-assisted development for automating some repetitive tasks. Tasks which, for example, writing test cases on the developer side, tasks that were probably assigned to maybe some developer who's new to the team, who's picking up a new language. All those tasks we are seeing that are now being sort of being handed over to AI. And this actually acts as a really good pilot project we have seen for a lot of organizations. Also, we are seeing a lot of QA teams are now using AI for running automated test, running mobile tests. A lot of that is now being assisted by AI models. And like you saw in our example, even security platforms are now using AI. So I think the point I'm trying to make is, of course, we have seen a lot of organizations investing in creating private LLMs. There is a strong roadmap with a lot of these organizations to create their own private LLMs, and I think they have seen the need to keep checks and balances in place for their AI models, because I think the risk is pretty clear.
Thank you. Are there, I'm just trying to see if there's some more Q&A questions. Ruby, do we want to open the microphones at this stage in case